Hello friends, this video on p-block elements part 4 is brought to you by examfear.com. No more fear from exam. Now we'll talk about the ionization enthalpy. So ionization enthalpy, if you see these are the values we have posted. Ionization enthalpy, as I told, is nothing but the amount of energy required to plug one electron. Correct? From Na to Na plus. So if you see the amount of energy required, this is all amount of energy required. So it is plus. So this is increasing because more and more amount of energy is required. If you talk about the sodium, which is not in this group but in the S group, sodium has tendency to become Na plus easily because it's more stable. So less energy will be required in that case. But if you talk about fluorine, for example, in this case, fluorine is talk about the fluorine, 1s2, 2s2, 2p5, right? So fluorine outermost cell has 7 electrons, so it needs 1 electron to become stable. So fluorine to fluorine minus will become very easy. But if you are telling fluorine to give me 1 electron, fluorine will not do it because fluorine is almost stable. It just needs 1 electron to become stable. Stable is 8 electron, the full filled state, and also half filled is stable. So anyway, I'll not discuss much again. We have discussed this in the previous videos, so you can watch that. So fluorine just needs 1 electron to become stable. So fluorine will not like to give 1 electron back. So you need really, you need to really provide very high energy to pluck 1 electron from fluorine. Similarly, noble gases, they are happy, they are noble, they are stable, right? They are stable. They don't want any kind of transactions now as far as electron is concerned. They are very happy in their life. They won't give electron, they won't take electron. So in this case, the ionization enthalpy is all the more high. But if you talk about boron, it is 1s2, 2s2, 2p1. Right? So in case of boron, it has 3 electrons. So either it needs 5 electron to be happy, right? Boron has outermost 3 electrons. So it needs either 5 electrons to be happy, or it can give 3 electrons to be happy. So it can give, right? It can give. So it needs only 800 kilojoules of energy to give 1 electron. So that's the math, it is, right? Everybody wants to be happy. So my neon is already happy, it won't give electron. You really need very high energy to convince neon to give 1 electron. Similarly, fluorine, it won't give electron. You really need high energy to convince fluorine to give electron. But boron, you can easily convince boron because if boron gives 3 electron, boron will become happy. So you can easily convince. But if you talk, and if you go down the group also, the ionization enthalpy decrease because since the group is size is more, right? It is easy to pluck electron. What we are talking about is plucking electron, right? If you talk from, let's suppose you go from carbon, right? If you go down, so carbon, the size is less, difficult to pluck electron. If you go to silicon, size is little more, easy to pluck electron. Germanium, size is all the more easy to pluck electron. The trend continues as you go down the group. Correct. The next is the electron gain enthalpy. So electron gain enthalpy, as I told, is the amount of energy released when isolated gaseous item accepts 1 electron to become gaseous. Iron, for example, chlorine will become Cl minus, right? So it will take 1 electron. It is about taking electron. It is not giving electron. So in this case, if you see, most of the case the value is negative. That means they give energy when they accept electron. But some case, for example, if you talk about this my noble gas, the value is positive. That means you need energy to make them accept electron. See, fluorine has the highest negative value. That means the full fluorine gives the maximum energy back. Why? Because or these values, all these halogens. I'm comparing this now first, right? I'm going from left to right. So if you go from left to right, if you see, if we talk about oxygen, right? Oxygen, if you give 1 electron, Oxygen has now 6 valence electron in the outermost shell. Oxygen gets 7. But if you oxygen lose one more electron, oxygen gets 8 valence electron. Right? Oxygen gains one more electron, oxygen gets 8 valence electron, and it is very happy. So oxygen has a reason to lose electron. So if you see oxygen lose electron and gives this much energy, but the energy is less. Why? Because after giving one electron, it is not very much stable. It has to lose one more electron to become stable. But if you talk about fluorine, it has 7 valence electron. Right? Now the moment it gives one electron, it has 8 valence electron. It's a very, very stable state. So fluorine will emit more energy to go from F to F minus. But if you see the nitrogen has the plus 31. Why nitrogen? If you see the nitrogen has how many? Nitrogen has 5 valence electron. Correct. But if you talk about the electronic configuration, 1s2, 2s2, 2p3. So if you see this outermost is half filled. Half filled means it is stable. It got stable, right? So if it accepts one electron, it becomes 2p4. That is not much stable. That is not half filled, because half filled also gives extra stability. So nitrogen will not have tendency to lose electron or to gain electron, right? So in that case, electron gain enthalpy is positive. So there are so many factors which decide actually. I recommend you to pause this video and just see all the values of electron gain enthalpy and just visualize why it is so. Why carbon gives so much energy when it loses electron. Why nitrogen doesn't give. Maybe the nitrogen has extra stability. Right? And if you go down the group, also if you see the amount of energy emitted is less. Why? Because the size of electron has increased, right? Nobody is bothering much if you're adding electron or if you're gaining electron. If, for example, here also fluorine, chlorine, bromine, iodine, right? This case is different. Chlorine gives all the more higher, it emits more energy when chlorine becomes Cl minus. But if you talk about the bromine, little less. Iodine, all the more less. But if you talk about the noble gas, these values are all positive. Why? Because they are noble gas. They are happy in their life. They don't want electron. They don't want to lose electron. Right? They don't want an electron. Extra electron, if you give them, they become unstable. They are happy with their stable configuration. So they have a positive electron gain enthalpy. This is a typical train. Right? So if you see, I have noted down the group 15 nitrogen has low electron gain enthalpy, this one, because it has half filled valence orbital. And noble gas has 0, I won't say 0, it has positive electron gain enthalpy. You see, right, it has all positive electron gain enthalpy. Why? Because they are happy in their life. The next trend is the electronegativity. Right? So if you see the electronegativity trend, the electronegativity increase from left to right. You see, this is boron is 2.4, 2.55, 3, 3.4, 3.9, and it increased. Why? Why did the electronegativity increase? See, electronegativity is what? The tendency to attract electrons, right? So if it is smaller in size and if it has more power here, the nucleus, it can attract electron more. For example, if you see boron will not be able to attract electron, but if you talk about this fluorine, it will be able to attract electron, because fluorine atom is more charged, more positively charged, and this whole thing is small. So even if electron is here, it will plug easily. But if in this case, even if electron is here in the same distance, it will not be able to plug. Why? Because the boron size itself is big first. Plus it doesn't have much positive charge in the nucleus. But in this case, even if it is here, it has so much positive charge in the nucleus, it will attract the electron. So electronegativity is nothing but tendency to attract electron. So if you go from left to right, the size decrease, and also the atomic, if you see the atomic structure, the nucleus has more positive charge. So, right, the capacity to attract external electron increase. So the electronegativity increase when you go from left to right. Same thing if you go from top to bottom, the electronegativity decrease. Why? The atomic size is more and the tendency to attract electron is less. Right? It's all about tendency to attract electron. I'll not discuss in detail. Anyway, we have discussed this in the previous chapter or in the Trends periodic table trend. You can watch that video to understand this in more detail. Right? So as I told, electronegativity is nothing but tendency of atom to pull shared pair of electron towards itself, and for that it needs the two things that favors is, the first thing is the small size of the the small size of the atom, and the second is high positive charge in the nucleus of the atom. You see, it depends on the atomic size and electron hunger, right? Two things. See, fluorine is all the more electronegative because fluorine wants one more electron to become more stable. So it's all the electron hungerness and the capacity to attract electron. That depends on the size of electron and the positive charge in the nucleus. And in this case, the aluminum and silicon breaks the trend somewhere. So if you go down, so if you see this decreased and there is an increase here. Similarly, this decreased and this increased here. So they generally break the trend in this p block levels. The metallic character, again the same thing. If you go from left to right and in this fashion from bottom to top, the non-metallic character increases. So if you see here, these values are my metals. These are my metals. The gray, brown one is my metalloids, and apart from these are my non-metals. Right? This is my non-metal. This is my metal, and these are my metalloids. Correct? So from metal to non-metal, you go from here to here. Metal, metalloids, non-metal. Correct? Now we'll talk about the oxidation states. So if you see the oxidation state, as I told, the group 13 maximum oxidation is +3, group 14 +4. So if you want to find the maximum oxidation state, you say group number -10. 13 maximum oxidation is 3, 14 maximum oxidation is +4, 15 +5, 16 +6, 17 +7, and 18 is +8. Okay, and please note we have both positive and negative oxidation state. You will see there is a negative oxidation state, there is a positive oxidation state. We'll discuss about these things in detail.
Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.